Hello everyone, my name is Praful Kumar and I'm recording this video for subject design and analysis of reconfigurable systems. And in this project we'll be designing a C code in which it will calculate the moving average. So it's gonna take the last 8 inputs and then it gonna calculate the moving average for them, and then it's gonna dump the output via 7-segment display. So I'm going to show you how you can do that in Cyber Workbench. So we'll be using HLS tool, that's a Cyber Workbench created by NEC. So for that you have to go to file, you have to click on new workspace. So you have to name a workspace and then give the project directory. So since I've already created a new project, so I'm going to show that to you. So I've created a project called AV8, and then if I show you the project option, so and this circuit I'm gonna having the clock period as 20 nanosecond and the frequency for this is 50 megahertz. So I'll be using BDL language for this. So the family of my FPGA is Cyclone 5, grade is -6, and then the device name is 5CSEMA5, package name is FC31. So we'll be using Cortex 2 logic synthesis tool. So all these are project options I've selected. I'm gonna click OK. Okay, so now I have to add a source file here since I've already added the C code. So this basically has a buffer, so it's gonna take the last 8 inputs and store them into an array. And if you can see, I have used a for loop wherein the buffer starts shifting into the array once we press the button. So if you can see here, this code, it's gonna add the last 8 inputs and put them into a variable called sum. So sum will basically calculate the moving average. So let's say if we give input as 8, it's gonna be 8 by 8, that is 1, so it will return the output 1. So once it's done, I'm gonna right click on this and click on analyze. So what this does is it will parse the C code and then it will create a light blue folder. And here if you see, so this is the synthesized RTL code it has created. So this is the synthesized RTL code. So if we want to make the constraints, if you want to declare some constraints, you right click on this. So you right click on this and then what you do is you click on generate constraint, click on flib or fcount. So once you can see the constraints here, this is the flib and this is the fcount constraints. Okay, so now I'm going to show you how you can do simulation in this. So this is software simulation. So in software simulation what we are doing is we are passing an input file and it's gonna generate output for that file. So what I'll do is I'll right click on this, click on import. So this is nothing but the input file. I'm gonna click OK, import the file, overwrite it. Yeah, I'm gonna right click on this. In a simulation scenario, so we have to make some adjustments here. So in this I'll select no. So in this it's gonna be decimal and every cycle. In this you have to select preprocessor direct definition, that is C. Okay, yeah, that is it. Since I've already done all of it, I'm gonna click on build. So the build has been started. So since it's throwing an error, that is libgmp, so I'm gonna try that in CUI. So okay, so here is my workspace for that directory. So I've created a make file. I've ran the make file. So once that is done, I'm gonna run the executable file. So once I've executed the file, you can see I'm gonna show you in the directory. Okay, so here's the output data file that has been created. So this is the output data. This is gonna be the golden output data we are gonna use to generate the cycle accurate simulation also. Okay, once that is done, So I have the input that is here, and the output, the golden output data that we got from the software simulation. I'm going to right click on this, I'm going to click build. So as it's throwing an error, I have to run that into CUI only. So okay, here is the window. Okay, I'm gonna run the make file. Okay, now once it's successful, I'm gonna run the executable. As you can see, the matches have been successful, so we have got 24 matches with 0 errors. So this is how the cycle accurate simulation works. Thank you.